Okay, here's an Alex problem that might seem a little bit tricky at first, but it's actually quite doable. It says, here is a graph of the molarity of ethanol in some vessel during some reaction. And it wants us to use this graph to answer the questions in the table below. So the way that you can use the graph is you can use this tool here, which will draw the lines necessary that you need in order for you to get the right tangent line, because we'll have to use a tangent line, which is that diagonal line, and then we'll have to get the right values that are going to be on the x and the y axis as well. So that's how we'll use that. Okay, so let's go ahead and read the problem. So it says, is ethanol being created or destroyed by the chemical reaction? You can see here that the concentration of ethanol definitely goes down over time. It is being destroyed in this reaction. It is a reactant. So it is definitely being destroyed here. Okay, it says if it's being created or destroyed, what is the rate at which it is being created or destroyed? 9 seconds. It wants an instantaneous rate at 9 seconds after the reaction starts. Okay, so let's see, let's go ahead and draw that tangent line at 9 seconds. So I got my little tool here, and so 9 seconds is going to be right here. So I'm going to draw that tangent line, and it is giving me the things that I need. So I can see that it crosses, the tangent line crosses the axis at the x-axis at 22 seconds. Crosses the y-axis at 0.0207 molar that you can see right there. Okay, so I have my tangent line drawn. Okay, and it also is telling me at 9 seconds right here the concentration, and of course it tells me the time right here. Okay, so let's see if we can answer these questions real quick. Okay, so it wants to know the instantaneous rate at exactly 9 seconds, and it wants it at 2 sig figs. Well, what I can do is I can see that, okay, from 0 to 22, that's a magnitude of 22, and from 0 to 0.0207. So in order to calculate the point at that tangent line, I can take this value right here, 0.0207. Okay, so let's go ahead and calculate that. 0.0207 divided by, it's going to be, we cross the x-axis at 22. Okay, so it's going to be at 22, and that is going to equal 0.0009. So 9.4 times 10 to the minus fourth, okay, is where it's going to be. So, and that is going to be in molarity per second. Okay, so that is going to be then 9.4 times 10 to the negative fourth, and my units are going to be molarity, okay, per second. Alright, so I should be good to go right there. Okay, that's asking for the average rate during those 9 seconds, and I don't have something to write with just at the moment, but the average rate is going to be over those 9 seconds, the change from the initial, okay, to the final. So it's going to be the final minus the initial divided by the change in time, which is going to be 9 seconds. Okay, so the initial is right here, and there's the final. So let's get that magnitude. It's going to be 0.0244. Let me clear that first. 0.0244. It's going to be minus 0.0122. Okay, so it's going to give me 0.0244 minus 0.0122, and then it's going to be divided by, if you remember from our lecture, divided by the time to give us the average. So that's going to be 1.3. I think it wants it in 2 sig figs, so it's going to be 1.4 times 10 to the negative third. Okay, so it's going to be 1.4 times 10 to the negative third. Okay, we want to get our units right, so it's going to be in molarity per second. Okay, so we are able then to, using the tangent line, calculating the slope of that tangent line at that point, then we are able to then to get here the instantaneous rate, okay, by drawing that tangent line, and then also we're able to get the average rate by taking the change in concentration, okay, over the interval that we're interested in. So if we click on check here, we should be able to get these right, and we did. Okay, so you can do this again, use that tool to draw the tangent line, and then calculate the instantaneous by getting that slope of the tangent line, and then also getting the average by taking the initial concentration, and since we're being taken away, it's being consumed, then we'll go to the concentration at 9 seconds divided by those 9 seconds, and that will give us the average.